So in this class, we shall move to the next unit, that is vector. So this chapter plays an important role in all the fields of engineering. It is very important in understanding or in making simplified form of many engineering problems into simple. So first, let us go to the physics, because this chapter we deal in depth in physics first. There are some quantities we come across in our daily life, say length, mass, time, area, force, etc. They are all the physical quantities. Why they are said to be physical quantities? Because we can measure all these quantities. We can measure length of any object, we can measure mass of any object, time of any duration, area of any room or anything, force, we can also measure how much force is applied on some object. All these things are measurable things, measurable quantities, hence they will be called as physical quantities. Physical quantities. Physical quantities are nothing but measurable quantities, right? These measurable quantities we can divide it into two types of physical quantities based on their direction or based on their magnitude or both. We will divide these physical quantities into two types, that is scalar and vector. Scalars and vectors. So first we know what is physical quantity. It is a measurable quantity. They are all measurable things, since we call it as measurable quantities are called physical quantities, right? These physical quantities are of two types, a scalar as well as a vector. Then let us define what is scalar and what is vector. The vector or a scalar is a physical quantity. A scalar quantity is a physical quantity having only magnitude. It is having only magnitude. That type of physical quantities are called scalars. What about vector? Vector is a physical quantity having both magnitude and direction. I will explain you what is magnitude and what is direction, right? Scalar example: mass, time, area, volume. All these things, they will not depend on the direction. Mass does not depend on direction, time does not depend on direction, area, volume, they are not depend on the direction. Therefore, they are said to be a scalar, right? Vector: displacement, velocity, force, acceleration. They are all said to be vectors. Why they are said to be vector? Displacement, it is nothing but change of position of a body in a particular direction. This is definition. You see, the direction is included. So it is having magnitude and direction. Velocity, let us say a car is traveling in a north direction with a velocity of 20 km/h. If I say velocity of car is 20 km/h due north. So in which direction car is traveling? It is traveling in the north direction. So direction is included. This 20 will be the numerical value. So every hour it covers 20 kilometer. That will be the magnitude of car. And what is the direction of velocity? It is towards north direction. Hence, this is a vector quantity, right? Velocity having both magnitude and direction. This is the difference between scalar and vector. We can represent the vector, whereas we cannot represent the scalar. For example, I give you an instant. A body is moving from A to B. So, if I don't say the particular direction, it can travel in any direction and it can reach to the point B. So this is said to be what? It is a scalar. It is having no direction. So hence we cannot represent it. Whereas we can represent, because there should be a particular direction from A to B. It would reach B in a particular direction. So if it goes in this direction, it will not reach the point B. Hence, it is having a particular direction. Hence, vectors are representable. Scalars are not representable. Okay. Then, how we can represent a vector? Representation of a vector. We represent a vector with a straight line or a line segment with an arrow. With an arrow. This is the representation of a vector. How do we represent a vector? Vector is represented by a straight line with an arrow, right? Suppose this point is A, this point is B. The vector can always be denoted by a small case with an arrow over the head. A over the head, there is an arrow. B, small case over the head, there is an arrow. That is the indication of vector. Here, in this vector, A will be the initial point. This is B is terminal point. A is initial point, B is terminal point. Then magnitude will be the length of a line. The length of a line always indicates the magnitude. So magnitude is always denoted by this A, B, vector AB, which is taken in between the two lines. How it is read? It is read as magnitude of vector AB. So AB is taken as what? A. Therefore, magnitude of this can also be denoted like this. This is read as what? Magnitude of vector A. This is the representation of a vector, right? Next, let us discuss what are the types of vectors. We have different types of vectors. Let us define one by one. Types of vectors. Null vector. Null vector. A vector having magnitude is equal to 0. Any vector, if its magnitude is equal to 0, such vector is called as null vector, right? Next one, unit vector. Unit vector. A vector having magnitude is equal to 1. A vector having magnitude is equal to 1. Such vector is known as unit vector, right? Unit vector, or say, if I take a vector A, this vector is always associated with a unit vector. Along the vector A, there will be a unit vector. What is unit vector? Unit vector is a vector whose magnitude is equal to 1. It is always denoted. Unit vectors are all denoted by a small letter with cap over the head. See, a cap means what? Unit vector of A. I cap, it is unit vector I. Unit vector J, unit vector K, unit vector N. Let us take a vector A. Along the vector A, there will be a unit vector. Along A, there will be a unit vector, that is A cap. So, a vector is always equal to magnitude of vector and unit vector. It is what? It is always a vector whose magnitude and its unit vector. Therefore, from this we can write what is unit vector? Unit vector is equal to vector A divided by whose magnitude. So it gives you the expression for unit vector. With this, we can find out unit vector along any vector or unit vector parallel to any vector. Right? Suppose if I want to find out unit vector along B, what is it? It is equal to vector B divided by its magnitude. If I want to get unit vector along A plus B, unit vector along A plus B, that is equal to what? Unit vector along A plus B is given by vector A plus B divided by whose magnitude. So totally you can remember it as unit vector is nothing but vector divided by whose magnitude. Unit vector of B is what? Vector B divided by its magnitude. Unit vector of A is what? Vector of A divided by its magnitude. Unit vector along AB, A plus B is what? It is vector A plus B divided by its magnitude. Let us work out few problems on the unit vector later on. Okay. Now we got the definition of null vector whose magnitude is 0. Unit vector, vector having magnitude is equal to 1. Next type, like and unlike vectors. So as we know that like vectors, unlike vectors means what? Vectors having same direction. Vectors having same directions are said to be like vectors. Vectors having opposite directions. Vectors having opposite direction, they are said to be what? Unlike vectors. Okay. Next type, co-initial vectors. The literature meaning of co-initial is what? Co means same, initial, starting point. If number of vectors are said to be co-initial vectors, if they start from the same point. See, this is vector A, this is vector B, this is vector C. They are starting from same point. Is it right? O will be the starting point. They are said to be what? Co-initial point. Vectors are said to be co-initial vectors if they start with same point. Collinear vectors. Collinear vectors. Collinear. Linearity means in the same direction. Co. In same direction. If number of vectors are acting, they are said to be what? Collinear vectors. Collinear vectors are nothing but what? The vectors A, vector B are on the same line. Same line. They are said to be collinear vectors. Right? Coplanar. Coplanar vectors. Plane. So if I take a plane like this, If number of vectors are acting in the same plane, such vectors are said to be coplanar vectors. Coplanar vectors are nothing but the number of vectors are said to be coplanar if they are acting in the same plane. Suppose this is a plane of board. In the plane of board, if n number of vectors are acting, all they are said to be coplanar vectors, right? These are the some of the important types of vectors. Null vector whose magnitude is 0, unit vector whose magnitude is equal to 1. The formula to get unit vector is nothing but unit vector is equal to vector divided by its magnitude, right? Next, like and unlike vectors. Like vector means vectors in the same direction. Unlike vectors means vectors in the opposite direction. Co-initial vectors, the vectors are having their initial points at same. That vectors are called co-initial vectors. Collinear vectors, the vectors lying on same line, they are said to be collinear. Coplanar vectors lying in the same plane, they are said to be coplanar vectors, right? So these are some of the important types of vectors. Next, let us move to the how to add the vectors or how to subtract the vectors. Addition. Addition of vectors in terms of line segment. Line segment. How to add two vectors on paper, on board. Let us take two vectors A and B. If I add these two, I should use the laws of vectors. I cannot add them directly, right? Because they are having both magnitude and direction. The scalar quantities can be added directly, but vector quantities cannot be added directly. We should use the laws of vectors. We can add by using triangular law of vectors. Triangular law of vectors. I will take two vectors A and B. If A and B are two vectors are having both magnitude and direction. If they are taken along the two sides of a triangle, this is vector A, this is vector B. Then their sum, what is their sum? Their sum is A plus B, will be considered along the third side of the triangle in reverse order. See, it is moving in this direction, so we are taking in this reverse direction. A, B, C. This is C. C will be the A plus B. This is called addition of two vector using the triangle law. Suppose vector A is AB, vector B is BC. Then according to this, AC is sum of the two vectors A plus B. That gives you AB plus BC. AB plus BC. This is one law we use for addition of vectors, right? There are other laws also. Let us take another law which is important to add the two vectors. That is parallelogram of law of vectors. Vectors for addition. This is also important. Let us take two vectors A and B. A and B are two vectors having both magnitude and direction. Both A and B are having both magnitude and direction. If they are considered along the two adjacent sides of a parallelogram, complete this parallelogram. then there will be a diagonal, right? So this diagonal will be the sum of the two forces, A, B, C, D. So as we know that what is parallelogram? It is a quadrilateral in which opposite sides are equal and diagonals are not equal. See the figure. AB is equal to DC and AD is equal to BC. So this is a vector BC parallel to B, and this is vector DC parallel to AB. Then sum of these two vectors will be represented along the diagonal of the parallelogram through the common point at which both the vectors are acting. Hence A plus B is always along the diagonal. Therefore AC is equal to AB plus BC. This is the addition of two vectors. Suppose we have more than two vectors. Then we don't use these two. These two laws are used only to add the two vectors. Suppose if we have more than two vectors, then we should use law of polygon of vectors. Poly means many, more than two. Next, how to subtract a vector in another vector. Subtraction of vectors. See, for a vector B, the negative vector is minus B. So what the negative sign indicates? There is a opposite direction. That's all. B and minus B are the two vectors having same magnitude but opposite direction. For B, the negative vector of B is minus B. Then a vector difference of these two vectors A and B, or subtraction of A and B, is given by A minus B, which is nothing but addition of A and minus B. We are adding vector A and negative vector of B. That is called subtraction of vectors A and B. See, I take the triangle. This is vector A. This is vector B. Their sum is equal to what? According to triangle law, A plus B. Is it right? So this is vector B. This is what? This is minus of B. Correct? Because direction is opposite. Then this will be the A minus B. Correct? This is A minus B. Or it is always taken as A plus of minus B. That is A minus B can always be taken as A plus of minus B. Then in this way we will subtract a vector in another vector. Right? So we got how to add the two vectors and how to subtract a vector in another vector. Okay. Then let us take a vector in a plane or in a space. Before taking a point, let us discuss position vector of a point. Position vector of a point. Take a point. Let P of x comma y be any point. Any point. P of x comma y be any point. Then see, this is xy plane. The point is P whose coordinates are x comma y. This point, if it is joined to the origin, origin is what? O. This line OP always gives you the position vector of the point P. P is what? It is any point which is taken in XY plane. Okay. Just that point is joined straightly to the origin. That gives you what? OP. OP will be the position vector of the point P. Position vector of that point P. Right? Then for any point P whose position vector is OP. Suppose A is any point whose position vector is what? OA. B is any point whose position vector is what? OB. We can also get the magnitude of position vectors. Magnitude of position vector OA is what? We will write like this. Magnitude of OA. We can also get the magnitude of B, position vector of point B, which is denoted like this. This is the position vector of a point. You take any point, to that point, just include O, that is origin. It is nothing but the line from origin to that point will be the position vector. Right? Next, vector between 2 points. Vector between 2 points are representing a vector in terms of or by means of position vectors. By means of position vectors. Consider 2 points. One is P, other one is Q. There are 2 points P and Q. They are the different points. So if I join them to origin, OP and OQ, they will be the position vector of those points. Now I need vector PQ. Then I need vector PQ. So PQ is a vector. Then how to get the position? How to get the vector PQ in terms of position vector? See the diagram. OP is position vector of point P. OQ is the position vector of point Q. I need vector PQ. It is in terms of position vector, right? Using triangle law, what the triangle law states? What the triangle law says? The triangle law says that this is OP plus OQ. OQ always equal to, sorry, this is PQ. I will take the vector PQ. PQ plus OQ is equal to OP. Sorry, plus. According to the triangle law. According to the triangle law is what? A plus B is equal to A plus B, right? A plus B is equal to A plus B. According to that, PQ plus I should take OP. This is OP, this is OQ. OQ is equal to OP plus PQ. This is considered A, this is considered as B, this is AB. Hence, this is what? A plus B. OP plus PQ, that gives you OQ. Hence, I need vector PQ. I need vector PQ, which is equal to what? OQ minus transfer this to the right side. It become what? OP. This is the vector PQ in terms of their position vector. Assume this. This is position. Sorry. It is a position vector of Q. This is position vector of P. So what the vector says? Vector between 2 points is always position vector of terminal point minus position vector of initial point. Position vector of terminal point minus position vector of initial point. That gives you vector in terms of position vector. Okay. Suppose if you want to calculate vector between AB, if you want to calculate vector between AB, how to get it? I need vector AB. How to get it? Position vector of terminal point, which is terminal point here, B, minus position vector of initial point, that is A. Suppose I want to know NM, vector between 2 points, NM. In this vector, NM, which is terminal point, M is the terminal point, which is initial point, N is the initial point. Therefore, OM minus OM. In this way, we can get the vector in terms of their position vectors, right? Vector in a plane. Vector in a plane. So we have x plane, xy plane, xy plane. Take a point P. Take a point P whose coordinates are x, y. Right? OP will be the position vector of point P. Draw PM perpendicular to OX. Draw PM perpendicular to OX. Right? So when these are the coordinates x and y, what is x? X will be the perpendicular distance from the point to y axis. This is x, correct? What is y? This is abscissa. It is perpendicular distance from the point to the x axis. This is y. Now OM. What is OM? OM is a component of this position vector. OM will be taken as x. OM is x and PM is equal to what? PM is equal to y. So as I said earlier, if I take a vector, it is always be equal to magnitude of that vector into unit vector along that direction, right? So if I take their position vector OM, magnitude of OM into position vector along OM. What is position vector along OM? Along x-axis is what? I. Therefore, it is x into I. Right? OM is a distance x, PM is a distance y. Right? So I write its position vectors. Position vector of OM, point P is what? OM. Any vector is equal to what? Magnitude of that vector into unit vector. What is that? Unit vector, that is equal to I. Hence, x into I. Similarly, PM, vector PM is equal to magnitude of PM into along the PM. What is unit vector? It is J, right? J. So, it is equal to Y into J. Therefore, I need OP. OP is equal to OM plus PM, or OP is equal to OM is what? Xi plus PM is what? Yj. Sorry, Yj. This is the vector in plane, that is two-dimensional vector. It is two-dimensional vector xi plus yj. To know the magnitude of that position vector, use Pythagoras theorem. Use Pythagoras theorem. What the Pythagoras theorem says? OP square is equal to OM square plus PM square. Is it right? If I take magnitude of OP is equal to magnitude of OM square plus magnitude of PM square. That is, it is what? OP square is equal to, it is OM x square I. Magnitude of I is equal to 1. PM square, that is y square. What is magnitude of j? That is equal to 1. Hence, OP is equal to what? Root of x square plus y square. That is magnitude of position vector in plane. In plane will be equal to what? Root of x square plus y square. So same thing we can express for the 3 dimension, that is in space. Now we have derived in 2 dimension, that is in a plane. In the same way we can derive it for a position vector in 3 dimension or in space. In space we can write directly OP is equal to xi plus yj plus zk. So I, j, k are unit vectors along x-axis, y-axis and z-axis. Its magnitude is equal to, magnitude of a vector in space is equal to x square plus y square plus z square. You can also derive it, right? So this is about basics of vectors, how a vector can be formed using a point, that is position vector, right? Next, let us take the vector operations. Vector operations in terms of components. Vector operations. Number 1, scalar multiplication. Scalar multiplication of a vector. As we know that scalar is a constant quantity. That constant can be multiplied with a vector. That is called as scalar multiplication. Some number, let us take m, is any constant. That is scalar. A is equal to a1i plus a2j plus a3k. B, any vector. Then scalar multiplication means m into a. M into a is scalar multiplication. Then how to get it? M a is nothing but all coefficients of ijk, all the constants of vector a should be multiplied with the constant m. That is called as scalar multiplication. See, that is equal to m into a is equal to m into a1i plus a2j plus a3k. All numbers of vector a, all components of vector a should be multiplied with what? M. That is equal to ma1i plus ma2j plus ma3k. This is known as scalar multiplication, right? Take a practical example. If a is equal to 3i plus 5j, minus 2k. So sometimes I don't write cap, so it is always understood that it is a unit vector. ijk, whether it is having cap or not, they will be considered as unit vectors. If they ask find 3a and 2a, see what is 3a? It is nothing but 3 into a. A is 3i plus 5j minus 2k. It is always be taken like this. 3 is multiplied with all the components of x, y, z axis. 3 into 3, 9i plus 3 into 5, 15j minus 3 into 2, 6k. It is 3a. To get 2a, see 2a, 2 is multiplied with all the components of the vectors a. That is 2 into 3, 6i plus 2 into 5, 10j minus 2 into 2, 4k. This is the way we can write or we can get scalar multiplication of a vector, right? The same way, how to add addition and subtraction of vectors by means of their components. By means of their components, that is ijk. If a is equal to some vector a1i plus a2j plus a3k and b is equal to b1i plus b2j plus b3k be the two vectors, then how to add these two or how to subtract? So addition, let us say addition, a plus b is equal to, right, according to this equation, what is a? a1i plus a2j plus a3k plus b, right, b, what is b? b1i plus b2j plus b3k. b1i plus b2j plus b3k. Remove the bracket. a1i plus a2j plus a3k. If there is a plus sign, no sign will change further, right? Plus b1i plus b2j plus b3k. So how to add algebraic terms? You take all the items together. a1i plus b1i. Like that, take together j terms. a2j plus b2j. a3k, b3k. a1 plus b1 into I. Correct? Take these two terms. In both the term, what is common? I have taken I is common. Remaining is what? a1 plus b1 plus a2 plus b2 into j. a2j plus b2j, which is by adding those two, we get b2 plus a2 plus b2 into j. Similarly, the third term, k terms are what? a3k plus b3k. That is a3 plus b3 into k. This gives you another vector. Say like xi plus yj plus zk. You can also find out its magnitude. Okay. Then how to subtract it? Subtraction of vectors. Just write a1i plus a2j plus a3k minus of b. What is b? b1i plus b2j plus b3k. That is equal to. Remove the brackets. Simple. So a1i plus a2j plus A3K minus of plus minus B1I minus into plus minus B2J minus into plus minus B3K. Now take common terms, that is A1I, B1I. What is the sign? Plus A1I minus B1I. If I take I common, what is remaining? A1 minus B1. In the same way, A2J minus B2J. If I take plus of J common, what is remaining? A2 minus B2. Plus, if I take K common, what is remaining? A3 minus B3. Again, it may become Xi plus Yj plus Zk. It is also another vector. Addition of two vector or subtraction of a vector in another vector, both will be resulted in a vector only, right? See, A plus B is always equal to B plus A. But A minus B is not at all equal to B minus A. But magnitude will be the same. Magnitude of A minus B is equal to magnitude of B minus A. So it will also true in case of addition. Magnitude of A plus B is equal to magnitude of B plus A. Now we got how to take a scalar multiplication of a vector and how to have addition of two vectors and subtraction of two vectors. We will discuss the multiplication of two vectors later on. Now let us work out few problems based on position vector, addition of vector, scalar multiplication and subtraction of vectors, right? Let A of 1 comma minus 3 comma minus 3 comma 2 be any point. Find its position vector PV. PV means position vector, and also its magnitude. Also its magnitude. Also its magnitude. Right? The given point is what? Point is A of 1 comma minus 3 comma 2. Therefore, position vector of A is taken as OA is equal to, just include I, J, K to the points. I, J, K to the point. That is 1I. Next, what is symbol? Minus 3J plus 2K. It is the position vector of point A. Just including I, J, K will be the proper vector. That is 1I minus 3J plus 2K. This is the position vector. Then magnitude of position vector is what? Magnitude of position vector is root of 1 square plus of minus 3 square plus of 2 square. So what is magnitude of a vector? Xi plus yj plus zk? It is root of x square plus y square plus z square. Correct? Now it is equal to what? Root of 1 square is 1 plus minus root 3 square is what? 9. Don't multiply this sign with this sign, because first we have to square it, then it should be multiplied with this plus. So minus 3 square, minus into minus plus 3 into 3, 9, plus 9 will be obtaining, that plus 9 into plus is equal to plus. That is equal to root 14. So it is better to write this step directly while getting the magnitude. sometime they will be multiplied. Some students will multiply this. So avoid this step. You can write directly. Square all the numbers in a vector, then add it. That gives you magnitude of any vector. Okay. Next question. If a of 2 comma minus 3 comma 4, 2 comma minus 3 comma 4, and b of 5 comma 3 comma 2, find vector AB magnitude. Find the vector AB magnitude. To get vector AB, first I need to get the magnitude, position vector of A, position vector of B, correct? Because A and B are different points. Write the PVs of A and B. That is, position vector of A is OA. Just include ijk to the numbers, that is 2i minus 4j plus 3j, 2i minus 3j plus 4k. And position vector of point B is what? OB. OB is equal to, what is the point B? 5, 3, 2. Just include ijk. 5i plus 3j plus 2k. Now we got position vectors of the 2 points A and B. Write AB. Vector AB in terms of position vector is what? It is position vector of terminal point minus position vector of initial point, which is terminal point B, which is initial point A. Therefore, OB minus OA, that is equal to, write them in bracket. What is OB? It is 5i plus 3j plus 2k, close the bracket, minus of, write OA in another bracket, that is OA is what? 2i minus 3j plus 4k. Remove the brackets. That is, AB is equal to, just I am removing the bracket, 5i plus 3j plus 2k, 5i plus 3j plus 2k. Here we don't have any sign to multiply. The plus is there with you. With that, if you multiply it, you will get same sign. Here minus is there. Means what? With all the elements of next vector, we should multiply with minus. Minus of 2i. Minus of 2i. Minus into minus, plus 3 into j, 3j, minus into plus, minus into plus, minus 4k. Okay. So this minus should be multiplied with all the elements in a bracket. Okay. Now add or subtract according to sign between the common elements. Which are the common elements? 5i and 2i. One is plus, other one is minus. We have to take difference, correct? Which is the bigger number? 5. Whose sign is 5? 5i minus 2i is 3i. Then plus 3j, add them, 6j. Plus 2k minus 4k, take subtraction, difference, 2k. This is vector AB. Now we need to get what? Magnitude of that vector AB. Therefore, magnitude of AB is equal to, put the root, then square all the numbers in a vector and add them. 3 square is what? 9. Just put plus. 6 square is 36. Plus 2 square is 4. So here is minus. So minus of minus become plus. That's why I told, just take the squares of all the numbers in a vector and add them, will give you the magnitude. That is equal to root of 36 plus 4 is 40. 49 is the magnitude of vector AB. Take one more problem on this. Let P of 2, minus 3, minus 1 and Q of 4, 2, minus 7 be any points. Find magnitude of QP. Magnitude of vector QP. So in the vector, which is initial point, which is terminal point. So P will be the terminal point, Q will be the initial point, right? PVs of P and Q are, write the PVs of P and Q. OP is equal to what? 2I minus 3J minus K, just including I, J, K. Next, OQ. OQ is what? 4I plus 2J minus 7K. We got position vectors of the points. We need QP. How to write a vector by means of position vector? It is position vector of terminal point, that is OP, minus position vector of initial point, that is Q, OQ. That is equal to, write OP. OP is 2I minus 3J minus K. Minus of OQ is what? 4I plus 2J minus 7K. That is equal to 2I minus 3J minus K. While removing the bracket, we should multiply with the behind sign, right? Minus of plus, minus 4I. Minus into plus, minus 2J. Minus into minus, plus 7K. That is equal to 2I minus 4I. 2I minus 4I. We should take addition or subtraction between common terms. 2I minus 4I is what? Minus 2I. Minus 3J minus 2J. Same sign. Add them. Minus 3 minus 2 is minus 5J. Minus K plus 7K. It is plus 6K. This is vector QP. Therefore, magnitude is what? Magnitude of QP is equal to root of, square the constants and add them. 4 plus 5 square, 25 plus 6 square, 36. It is equal to 36 plus 4, 40, 40 plus 25, 65 is the magnitude of QP. So this is the procedure we need to follow to find out any vector in terms of their position vectors, right? Take a problem on sum or difference. If A is equal to 3I plus 2J minus 5K and B is equal to 4I minus 7J plus 3K, find number 1 A plus B, number 2 A minus B, number 3 2A plus 3B, number 4 3A minus 5B. So they are given two vectors A and B. With this, we have to calculate the values of all these expressions, right? Let us work out one by one. First one, we are getting A plus B. Get A plus B. Write A is what? 3I plus 2J minus 5K. Plus of B. B is what? 4I minus 7j plus 3k. So while adding, these brackets are not necessary because sign will not be changed. You can write directly like this: 3i plus 2j minus 5k plus 4i minus 7j plus 3k. You can avoid this step, right? While adding the two vectors. Now 3i plus 4i both are positive, hence it become what? 7i plus 2j minus 7j plus 2j minus 7j will be the minus 5j minus 7k plus 3k is minus 2k. This is the vector a plus b. Second one, what is second expression? It is a minus b. So therefore a minus b is equal to, compulsorily you write it in bracket, otherwise it will be confused. So if you are perfect, you can write directly also. See, a, what is a? 3i plus 2j minus 5k. If you don't put the bracket, what to do? You have to write the subtrahend vector by changing all the signs. It is plus, it is minus, plus. While writing without bracket, what we need to write? Minus 4i plus 7j minus 3k. Otherwise, if you write it in bracket, it won't be confused. 4i minus 7j plus 3k. Now open the bracket. 3i plus 2j minus 5k minus 4i minus of minus plus 7j minus 3k. Repeat the same thing. Take common terms. 3i minus 4i. What is the difference? Minus 1i plus 2j plus 7j. It is plus 9j minus 5k minus 3k. Same sign are there. Just add them. 5 plus 3 is 8k. This is what? A minus b. The third expression is what? It is 2a plus 3b. 2a plus 3b. You write according to the given expression. That is 2a plus 3b. See, 2 into 2 into a. What is a? It is 3i plus 2j minus 5k. Close the bracket. Next, what symbol we have? We have plus, put plus. Then the number 3 into vector b. What is b? 4i minus 7j plus 3k. Open the bracket along with taking multiplication of the constant. 2 into 3, 6i plus 2 to the 4j plus into minus minus 10k. Is it right? Plus into plus plus 4 into 3, 12i plus into minus minus 7 3s are 21j plus into plus plus 9k. So 6i plus 12i is equal to 89 plus 4j minus 21. It is equal to 17j. Minus 10 plus 9, it is minus 1k. This is 2a plus 3b. Okay. Fourth one. What is fourth one? We need to calculate 3a minus 5b. So 3a minus 5b is equal to, just write according to the expression value. 3 into a. What is a? It is 3i plus 2j minus 5k minus of 5 into b. What is b? It is 4i minus 7j plus 3k. Open the brackets. 3 into 3, 9i plus into plus plus 3 to the 6j plus into minus minus 15k minus 20i plus 7 into 5, 35J, minus into plus, minus 5 3s are 15K. So finally you will get 9I minus 20I is what? Minus 11I. Plus 6J plus 35J is equal to plus 41J. Minus 15K minus 15K. Is it 30? So minus 30K. This is the expression value 3A minus 5B. Sometime they will ask you their magnitude also. So for example, if A is equal to 1 comma minus 3 comma 2 and B is equal to 2 comma 5 comma minus 3, find 2A minus 3B magnitude and A plus 2B magnitude. Take one by one. What is first one? It is magnitude of 2A minus 3B. I cannot calculate directly magnitude. So first I will calculate 2A minus 3B. So after getting the value of 2A minus 3B, I can get the magnitude of that. Okay. 2 into A. So I am writing this into ijk. 1I minus 3j plus 2k. I have given in point form. I am taking in vector form, right? Minus 3 into b, that is 2i plus 5j minus 3k. 2 into 1, 2i plus into minus minus 3 2s are 6j plus 4k. Minus 3 2s are 6i plus into minus minus 5 3s are 15j minus into minus plus 9k. It is equal to 2i minus 6i. It is minus 4i minus 6i minus 15. It is minus 21j plus 13k. Now I need to calculate the magnitude of 2a minus 3b. That is 2a minus 3b. 3b magnitude is equal to root of 4 square. It is 16. 21 square. 21 into 21. 21 1 21. 2 carries 21 into 2. 42. 44. 441. 13 square. That is 169. Finally, it is what? 9 plus 1 10. 16. 1 carries 6. 10. 11. 12. 2. 1. 6. 20. 6 is the magnitude of 2a minus 3b. Okay. Second one, magnitude of a plus 2b. First get a minus 2b. First get a minus 2b. Write a. What is a? A is I minus 3j plus 2k minus of 2 into b. What is b? 2i plus 5j minus 3k. That is equal to I minus 3j plus 2k minus 2 into 2. 4i minus 10j minus into minus plus 3 to the 6k, which is equal to I minus 4i. It is minus 3i minus 3j minus 10j. It is minus 13j plus 2k plus 6k. It is plus 8k. This is a minus 2b. Therefore, magnitude of a minus 2b is equal to root of minus 3 square 9 plus 13 square 169 plus 8 square 64. That is equal to 9 plus 9 18, 18 plus 4 22, 2 carries 6 plus 6 12, 12 plus 2 14, 1 carries 1 plus 1 is 2. So 242 is the magnitude of A minus 2B. So these are some of the examples on addition, subtraction and scalar multiplication. Okay. So you work out similar problems. So today we learned what is vector, what is scalar and types of vectors, and how to represent a vector. What are the methods included for addition of vectors and how to add, subtract and scalar multiply the vectors. Okay. So with this I conclude today's class. Enter.